so we're going to try to go a little bit fast. What I'd like you to do at first is I'd like you to spend a minute looking at each other's Jamboards, right? To look, hold on, stop share. To look at each other's Jamboards to see what people have written and see if you agree with what people have written or not. Okay, so look at each other's boards for a minute or two. Okay, so let's see. Let's start with, I don't know, you're still working on here. Let's start with this room. Ollie, Reed, and Casper. You guys want to talk to us about what you did?
Yeah, sure. So basically the first two, the coffee filters are a constant velocity because if you're holding it, then it's not, going up or down. And in the last one, if it's falling at a constant velocity, then obviously, the velocity is constant.
Mm-hmm.
And in the second one, the velocity is not constant because it's falling at a greater rate than the air can push back up on it. And yeah, I think that's it.
Okay. So you have put some congruency marks on your arrows. And one is I wanted us to make clear, like we understood what those congruency marks meant.
Yeah.
Please do not erase that congruency mark. Please do not erase that congruency mark.
Sorry.
No, it's okay, because that actually, I really like that congruency mark. So on the diagram on the diagram on the left, Noel, what do congruency marks mean?
That the forces acting on the victim are equal.
Somebody want to like improve that statement?
They're balanced forces.
Thank you, Dak. Yes, they're not. Why are they not equal, Noel?
Because they wouldn't necessarily be equal in order to be balanced.
Why are they balanced but not equal? We've only had this conversation 15 times, but yeah, Casper.
For them to be equal, they'd have to be pointing the same way. So balance just means that they're pointing different directions, but they're the same strength.
Got it. Okay. So I'm sorry. No, I didn't mean to put you on the spot, but you guys are going to be writing about this, and I want to make sure you're really careful about your vocabulary, right? So, but you're right. So if your congruency marks are there, that means that the two forces have the same size, or they're balanced, or they have the same magnitude. Same thing with the diagram on the right. Question: when you have three diagrams like that with congruency marks, the same congruency mark on all three diagrams, what does it mean? Technically. So when you have a congruency mark like this guy over here, right? But also this one, and then those ones, what does that mean when you put 5 congruency marks like that?
When I put them there, I thought like each force diagram was separate so it wouldn't go in between them.
Interesting.
But I suppose if it's the other way around, you could add more ticks.
So,
each.
Right, and the reason why I didn't want, so technically, if you have 3 diagrams and they all have the same congruency marks, everything that has the same congruency mark has the same size. Right? That is the definition of the congruency mark. Question is, should you have different congruency marks on your diagrams?
I mean, yeah, because I think they're separate forces.
Question is, did the force of gravity change on the coffee filters at any point during this experiment? It did not. So at the very least, all your force of gravity should have the same congruency mark because it's the same force of gravity. And then if you want your forces to be balanced, then they should also have the congruency mark. So it wasn't a mistake. Like that actually was a really good move, right?
Right,
You
okay.
put those congruency marks
Yeah,
at-
so it works.
It totally works, right? So I just want to make sure that okay, again, stopping sharing.